Here's an AP Calculus multiple choice question. This is actually from the Bluebook test preview, and it's a limit question right off the bat. So if you think about putting 0 in place of the x's in both the numerator and the denominator, what you get is you get a 0 in both spots. So if we end up with the indeterminate form 0 over 0, that does give us the green light to apply L'Hopital's rule. So what I'm going to do is I'm going to take the rate of change of the numerator, the rate of change of the denominator, and I'm going to compare the limit of the ratio of those rates of change. So it's probably beneficial for you to think about the numerator's second term as being written like this, because then it's hopefully obvious to you that when you take the derivative, you're going to need to use a couple of chain rules. So the derivative of the 1 is 0, so you don't see anything prior to the subtraction. There's the subtraction that copies in as a negative. I'm multiplying by the exponent, subtracting 1 from it. Inner function copies here. And then I need to multiply by the derivative of cosine of 2x. That's going to require another little chain rule. So the derivative of cosine is negative sine. I copy the inner function times the derivative of the inner function. Denominator, simplified that a little bit. Squaring 2x is going to give you 4x squared. A little easier to take the derivative here. That is going to get me a derivative of 8x. Now, I noticed that some stuff is able to clean up a little bit here. I have a negative times a negative within my numerator, so you see I took a positive sign for the numerator, and I have a 2 times 2 in the numerator, but then I have an 8 in the denominator, so that's going to leave me with a coefficient of 1 in the numerator and 2 in the denominator after I reduce that 4 over 8. Now, what I end up seeing is obviously I get to 0 again in the denominator when I put 0 in for the x. Limit of my numerator also is 0. Sine of 0 is 0. So I do one more application of L'Hopital's rule. So the derivative of the numerator is a bit messier this time around because now it's a product that's going to involve two minor chain rules. So when I do the derivative of cosine of 2x, derivative of cosine is negative sine, inner function copies there, times the derivative of the inner function. I'm going to multiply by the original second part of the product. I'm going to add on to that the original first part of the product, and then I need the derivative of sine of 2x to finish that off. The derivative of sine is cosine, inner function copies here, times the derivative of the inner function. Denominator's a lot nicer, derivative there is 2. Once that denominator becomes a 2, kind of indicates to me that we're going to get an end result here that's no longer indeterminate. If I put 0 in place of all of the x's in the numerator, sine of 0 is 0, so this initial term prior to the addition is going to give me a limit of 0, and then after the addition, cosine of 0 is 1 times cosine of 0 is 1 times 2 is 2, so I'm looking at 0 plus 2 over 2 and an end result of 1.